Okay, so we're in the middle of section 7.6. We left off, and we were, it said find all solutions real and complex of the equation 7x cubed plus 47x equals x to the fourth plus 27x squared plus 26. So first we need to get everything on one side of the equation, and we need to set it equal to 0. I'm going to start out with the x to the fourth. So I'm going to move everything to the right side. So I have x to the fourth minus 7x cubed plus 27x squared minus the 47x, and then plus 26. So I'm just moving the 7x cubed over and the 47x over. All right, and I need to do my p over q. Remember the rational roots theorem. So if I do my p over q, p comes from the factors of 26. So factors of 26 are 1, 2, 13, and 26. And factors of 1, right, the leading coefficient, so that's our q, is plus or minus 1. So we have 8 possibilities. We have 1, 2, 13, 26, negative 1, negative 2, negative 13, negative 26. Okay, and we're going to try these with synthetic division. So let's say I try 1 first. Okay, I have 1x to the fourth minus 7x cubed plus 27x squared minus 47 plus 26. I make sure I didn't miss any terms, right? X to the fourth cubed squared, x to the first, none. Drop the 1. 1 times 1 is 1, add straight down, negative 6, add straight down, 21, add straight down, and we're very lucky it worked. Yay. So what this has done is it's factored our polynomial into our divisor times the quotient. So the divisor came from the 1. It was just x minus 1, right? Because 1 was the solution. And then I now have x cubed minus 6x squared plus 21x minus 26. And we often will have factor by grouping work. In this case, it doesn't, though. Because if I split the middle, like don't write this, but if I split the middle, I pull out an x squared, so I have x minus 6. But there's no way to get an x minus 6 over here. So it's not going to work. Okay, so that means that we have to do this process again. So we find another number that works. So don't rule out 1. It could have multiplicity. It could work as well. But let's say we try like 2 or negative 2 or something. Let's say I try 2. I'm going to do my synthetic division. And I kind of continue on from that last step. Drop the 1. 2 times 1 is 2. Add straight down. I get negative 4. Negative 8. Oh, man, I'm so lucky today. 26. Add straight down. I get 0. This is also like the 4th time I've done this problem. That helps with my luck. All right. So I have x minus 1. And then now I have my x minus 2. And then I have x squared minus 4x plus 13. Okay, so that's coming from the quotient. Okay. All right, so this time it said find all solutions, real and complex. So if you remember on the last example, we were really lucky because it said find the rational solutions. So when it says find the rational, if it doesn't factor, like that last x squared thing, you're done. Because factoring gives you the rational solutions. But in this case, this does not factor. And we actually have to use the quadratic formula because it says find all solutions, the real and the complex answers. So we need anything that could have a square root or an I or whatever. So I do x equals negative b, so 4, plus or minus the square root of b squared, so 16, minus 4ac all over 2a. I feel like we did the same thing just the other day. So it's 4 plus or minus 16 minus 52. So we get negative 36 under the square root all over 2, which is 4 plus or minus 6i over 2. And remember, the 2 goes into both pieces. So you can like draw little arrows, or you can do a little heart thing. It doesn't matter what you want to do. So you have 4 over 2 is 2 plus or minus 3i. So let's count our solutions. So we had, from here we had 1. So x equals 1. From here we had 2. Then we had 2 plus 3i. And we had 2 minus 3i. So we have 4 solutions, which makes sense because our original was an x to the 4. So we're good. Making sense? I think on most of your homework problems it says find all solutions. Isn't that sad? All right, next up. Okay, an open box is to be made from a square piece of material, so maybe like cardboard or paper or whatever. That's 10 inches on each side. So it's 10 by 10. I feel like some of you guys didn't craft very much when you were little. I crafted all the time because my mom is a kindergarten teacher. So I've built about anything you could ever want to build out of paper and cardboard. So I understand this process. Some of you guys don't understand this. This is an important math problem. I know it seems stupid. Like, I'm never going to see this square piece of cardboard cut again. But you will see it in every single math class you do. Okay, so I'm gonna do a little demonstration for you. Okay, so we'll just pause this and I'll do a little demonstration. All right, so we folded up those little flappy things. We cut out like a little, we cut out these little squares, and then we fold up the flaps right here at the like fold line. Right, and then when we fold up those little flaps, oops, right, because it really looks like this now, we cut out the corners, we get an open top box, okay? And this open top box was really pretty shallow. It looks like that. I was an artist, I was an art major in college, art and math. All right. Yes, I know. All right, so I cut, this was 10 originally, and I cut out that little square. I'm going to make that square an x by x square. So make this x by x, x by x, x by x, x by x. So when I cut out this distance, which was x, and this distance, which is x, it makes this whole flap here, instead of being 10 minus 2x. Do you guys all see that? So we have 10 minus 2x. And then the same thing here, like this little flap right here is 10 minus 2x. But what is the height of the box? It is not 10 minus 2x. As you fold up this piece, so as I fold it up, how tall is my box? X. Okay, so I have a volume, length times width times height, of 10 minus 2x, 10 minus 2x times x. All right, and we want the volume to be 48 cubic inches. That's what it said in the problem. So I'm going to have 48 equals, and I'm going to multiply it all out. So 10 times 10 is 100. I have minus 20x, so I get minus 40x, plus 4x squared, but I still have that x. So I'm going to multiply that in. So I'm going to have a 4x cubed, right? I'm kind of writing in descending order as I do this. 4x cubed minus 40x squared plus 100x plus 40, or no, wait, minus 48 as I subtract it over, right? Minus 48 equals 0. And I'm going to try to solve for x. Okay, so I can make this easier on myself. I don't have to do p over q right now because my p is going to be all the factors of 48, which there's a lot of factors of 48. A lot. How can I make this easier on myself? Divide by 2? By 4, right. So I'm going to pull out the 4. So I have x cubed minus 10x squared plus 25x minus 12. Much easier. And you can divide that 4 over and it just goes away. Like 0 divided by 4 is still 0. So you don't have to worry about that 4. So now when I do my p over q, I have factors of 12, which are 1, 2, 3, 4, 6, and 12. And my factors of 1 are just plus or minus 1. Now here's where I think logically about this problem. I don't just start trying numbers. I don't try 1, I don't try negative 1. I start thinking about what I'm solving for. I'm trying to find x. X is the distance that you are cutting along the side of this box. Okay, x is not going to be 12. You cannot have a 10 by 10 piece of cardboard and decide that you want to cut 12 inches from both sides. That creates 24 inches across. Do you guys see what I'm saying? It's not possibly going to work. 12's out. You can't do negative numbers either, so you're not going to have the plus or minus either. It's only going to be positive numbers. What else can I not do? 6. And 1, although it might work, it's kind of tiny. I probably wouldn't even try 1 or 4 at the beginning, right? Because when you cut out 4 by 4, you're only going to have like a 2-inch distance. It's probably going to be 2 or 3. Okay, so how about everybody from Audrey to Will, you guys try 2, and everyone else, you guys try 3. So do your synthetic division. I got 3 worked. You didn't even finish your 2. Sorry, I robbed you of that. All right. So I've now factored into 4 times x minus 3 times x squared minus 7x plus 4. Now the x squared minus 7x plus 4 doesn't factor, but don't rule it out as a possibility. That could be an answer. Okay, so we're going to find both of those. So we're going to do the quadratic formula. So I have negative b, which is 7, plus or minus the square root of b squared, so 49, minus 4ac, so minus 16, all over 2a. So I get 7 plus or minus the square root of 33 over 2. So I'm going to get my calculator. I'm going to find the decimal answers for both of those. All right, if I do 7 plus the square root of 33 all over 2, I get 6.372. And if I do the 7 minus the square root of 33 divided by 2, I get 0.628. One of those does not work. Which one? Ah, no. Just because it's a tiny number doesn't mean it's the one that doesn't work. The 6th one. Why is it the 6.372? It's too big. You had a 10 by 10 square. You can't cut over 6 inches out of both sides of the square. Does that make sense? It's going to be like over 12 inches. It doesn't work. So we got to cross it out. So the one that does work is the 0.628. Now this creates a really funny looking box. Okay, if you only cut out like 0.628, which is really hard, like cut out 0.628 inches, like that's the weirdest instructions ever. But if we cut out 0.628 inches, it creates a really, really flat box, which still can have that volume. It has that volume of 48, so it works. It's still a solution. So don't rule out the ones where you have to do the quadratic formula. So we get x equals 3 from here, and we get x equals 0.628. It could be either one. All right, the irrational root theorem says if the polynomial p of x has rational coefficients and a plus the square root of b is a 0, then a minus the square root of b is also a 0. This comes from the quadratic formula, just like the I ones. Remember when we had like 2 plus 3i is a 0, then 2 minus 3i is also a 0. Same idea. It's coming from the quadratic formula. So let me show you an example. So it says identify all of the real roots of this. So if I do my p over q, my factors of 2 are plus or minus 1 and plus or minus 2. My factors of q are plus or minus 1 and plus or minus 2. So if I list all my possibilities, I have 1 and 2, and then I have 1 over 2, and I have 2 over 2, which is still just 1. So I have 1, 2, 1/2, -1, -2, -1/2. I've tried all the hard ones, or the easy ones, I guess. I've tried 1, I've tried 2, it doesn't work. I've tried -1 and -2, it doesn't work. It's a fraction. We got to go with it. Synthetic division with fractions often is not bad. So if I do 1/2 with my synthetic division, I have 2x cubed, -9x squared, 0x, and 2. Do not forget the 0. Had many people work on their homework and come to me and say, I tried every single one, none of them work. And I'm like, okay, we'll go back to step 1. You left out a 0. It's rough. So when you try 12 different things with synthetic division, that's when you learn to never leave off zeros. All right, drop the 2. 1/2 times 2 is 1. Add straight down, I get -8. 1/2 times -8 is -4. Add straight down, I get -4. 1/2 times -4 is -2. Add straight down, I get 0. It's not bad. Usually there's like even numbers where it's going to cancel out the 1/2. Okay, so we've now factored into x minus 1/2. I have 2x squared minus 8x minus 4. This always happens when you have fractions that work. Like, see how I can pull out a 2? I can actually put that 2 in with the x minus 1/2. It's like the original was 2x minus 1. Do you understand what I just did back there? So I pulled out a common factor and then I put it into the other parentheses. Okay, so I need the x squared minus 4x minus 2. It doesn't factor. So I use the quadratic formula. So I get x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So I have 4 plus or minus 16 plus 8, so square root of 24 over 2. How's square root of 24 reduce? 2 root 6 over 2. And then this 2 goes into both pieces. So I get x equals plus or minus, no, not plus or minus, 2 plus or minus root 6. Okay, I have 3 solutions. I have 2 plus root 6, I have 2 minus root 6, and I have the 1/2. Okay, see why the 2 plus root 6 and the 2 minus root 6 have to go together. It comes from the quadratic formula. Okay, so if you have a problem on your homework that says, write the simplest polynomial with 3 plus root 5 and negative 2, that means you would need to add in another thing. Instead of having 3 plus root 5 by itself, you have 3 plus root 5 and 3 minus root 5. Okay, so make sure that you have that, otherwise it's going to be a disaster when you're multiplying because you're going to have lots of square roots. Okay, so you need the conjugate. All right, let's play a Kahoot game.